You didn't print it out, just go through the steps. However, don't probably copy down all the given information. Okay, do you get what I'm saying? Like, don't just be a copy machine and copy this down, because you can go back and look at this later. This is due with your project. So you're going to come up with an idea of 2 things to sell and how much to sell them for and how much profit you make. And you're going to do an analysis of that fictional business that you create. So this is going to kind of walk you through it. And then this is due with the project. Like, you get points for having this done. So do it whether you printed it out or not. But you probably don't just want to randomly copy all the words at the top. That will take you like half the time that we are doing to get through this problem. Okay? Does that make sense to everybody? All right, so here's their situation. So they're raising money for homecoming, and ASB decides that they're going to do this fundraiser. And they decide to order cases of chocolate bars and cases of jarred popcorn. Okay? But they can't order any more than 400 candy bars and jars of popcorn together. Maybe because of space they have to store it or money they initially have to spend, but they have this limitation, like we can only get 400 things, okay? And they can't spend any more than $500. So they can only spend $500, they can only order 400 things, and they've got to figure out, if we've decided to sell these 2 things and these are our limitations, how can we make sure that we order the right amount of each thing to get the maximum profit, right? And so then here's the information about each individual thing. For the chocolate bars, you have to order them by cases, which complicates this problem a little bit, because we're not just getting like small components and large components. We're getting like a case of small components that comes in a certain size with a certain price and a case of large components. But we'll kind of break that apart to help us understand it better. So you order a case and it comes with 30 candy bars in the case. You pay $10 and you sell it for $1 per candy bar. Okay? And then the popcorn comes with 10 jars in a case. You pay $20 for the case and you sell them for $5 a jar. Is this okay with everybody? All right, and then that little chart just kind of summarizes what we just said. And now we're going to try and figure out what to do. So instead of just starting to randomly guess how many cases we should order of each, like we did with the Legos, we are going to go straight to the inequalities and try and use our limitations to get kind of a region of points and narrow down our possibilities. So the first thing we want to do if we're going to write the inequalities is we want to define some variables. Like in our problem, we use X for chairs and Y for tables because we were trying to figure out how many chairs and how many tables we should make. In this problem, you're trying to figure out how many cases of chocolate bars should I order and how many cases of popcorn. So is everybody first okay with what part of the problem becomes the variable? The variable is what you're trying to decide to use, okay? So small components and large components. Here, chocolate bars and popcorn jars. Okay, so our Hershey's bar cases of them is X, and our popcorn cases of them is Y. And so then total just means how would you express the total number of cases that you've ordered. Okay, so I ordered X amount of chocolate bar cases and Y amount of popcorn jar cases. So the total would just be X plus Y. Is that okay with everybody? All right, so I'm just kind of defining what I'm looking for first, figuring out a variable. But in order to analyze the profit, I don't sell them by case, right? So this problem has one extra layer of difficulty because you don't sell X for a certain amount and Y for a certain amount. Instead, you break it down per bar and per jar. So that's why we have to add this extra little thing here. You guys might not have that issue in your problem because you get to create your problem. So if I got to order chocolate bars individually and popcorn jars individually, I wouldn't have to even have the difference between the first and second line here. Is that okay with everybody? All right. So the number of units is what I'm actually getting. So who thinks they could tell us how we would express the number of units that goes in the Hershey bar column? So this is how many bars you're getting, not how many cases. Sherilyn? So I can order 400, we have to be careful, let's see. I can order 400 units. Because you don't know the exact value, you can't just say it. but we want to base it on this. So we've said X is the number of cases of candy bars that I'm ordering. How would I then express the actual amount of candy bars I'm getting if X is the cases? Brandon, say it louder. 30X. Are you guys okay with that? How did he pick 30X? 30 candy bars in each case. So I might order X cases, but I'm getting 30 times that is the number of candy bars that I'm getting because that's how they come in each case. So what would be the number of units that I'm ordering for the popcorn jars?
10.
Good. So 10 come per case there, so 10Y. And so if I want to add up how many items I've ordered in total, I would have to add 30X plus 10Y. So this first total is the total number of cases. The second total is the total number of units. Which one is actually going to be used more in this problem? Which one do we have information about? Units, right? So that's why we had to kind of like transfer it over that extra step because the limitation was about units. So even though we have to order in cases, we kind of want to like translate that into what it means in units so we can relate it to some of the information that was given to us at the beginning. Okay. All right, then we want to look at how much this is costing us. So the next row is about cost, okay? So cost of Hershey bars. So remember, X represents the number of cases. How much does it cost for each case? Yeah, $10. You guys see that up at the beginning? Okay. So the cost for me to order the candy bars is 10 times the number of cases. And what's going to be the cost that I should write down for the popcorn jars? 20Y. Are we okay with this? So if you guys don't know where we're getting that, okay, we're getting it back from up here about the amount that we pay. That shows our cost. And so if we wanted to know our total cost can be calculated this way, okay? Depending on how many candy bar cases and how many popcorn jar cases that we do. All right, and then profit. Okay, so let's look at those numbers and see what we're making in profit. And remember, profit is not just how much you make. It's only profit if it's more than what you bought it for, right? So when I look at how much I paid and how much I sell, so if I sell every candy bar for $1, how much money comes into my hand when I finish selling the case? $30, right? Is that pure profit? No, because I did buy the case. How much of it is profit? $20 because I paid $10 for the case. So my profit off of the Hershey bar cases is $20 for each case. And then we need to look at the same thing for the popcorn jars. Okay, we sell them for $5 a jar. So how much money comes into my hand when I'm finished selling a case of popcorn? $50. How much of that is profit? $30. Okay. And my total profit would then be calculated by adding those things together. All right, so why did I care about these? Why did I pick these? So I picked number of cases sheerly out of the information in the problem. That's the way I have to order the objects, and I'm trying to order them in the most efficient way, so those things become my variables, okay? Just like in the previous problem with Legos, you were trying to decide how many tables and how many chairs, those things become your variables, okay? Why then did I break it down to these things here? The same reason if you look at those 3 things we wrote on the back. These 3 things are important because of this. What are we trying to maximize in the problem? Profit. That's why this is here. I can't maximize profit if I don't know how to calculate my profit, okay? So that's the function I'm trying to maximize. Then why did I pick number of units and cost? Morgan? So that does affect the profit, okay? And we'd have to do that no matter what, but that doesn't necessarily mean I would pick it as one of these things here. Think about the 2 inequalities that I wrote back there. What were those things based on? Why could I write those and not some other inequality? Okay, one of those was about what? Like the one that says 3x plus 2y is less than or equal to 1200. What was that about? Small components. And why would I care about that? Because I had to follow a certain restriction that was placed on the number of small components. And that dictated that I had to write that down and make sure I wasn't breaking that restriction. And our other inequality from the Lego problem was based on large components, right? Because there was also a restriction there. In this problem, if you look back at the beginning, what are your restrictions? What are the things that you're limited in doing? Well, good. My limitations were that I can only have 400 items, and then I can only spend $500. Those things are dictating this right here. So I only cared about those things because those are the things that I have a rule on, okay, a limitation, and I can't break that limitation. Does that make sense to everybody? So I want a profit equation because that's what I'm trying to maximize. And the reason I focused on these other two areas is because in my problem, those were the things that had limitations, okay? So the next part of your notes says to write the restrictions and simplify them if possible, just to make your graphing easier. So in the problem, the two things that we just circled are the restrictions. The things that you said, oh, these are the rules I have to follow. So for us, the restrictions are here, okay? These two things, number of units and cost. And the restriction specifically said you can't go over 400 units. So that means this total that you wrote right here has to be less than or equal to 400. And then the restriction on our cost was that we couldn't spend more than $500. So those are our restrictions. I'm going to divide everything by 10 in both of those equations. Is that okay with everybody, to make the numbers a little bit simpler? So that first restriction would say 3x plus y is less than or equal to 40. And the second one would say x plus 2y is less than or equal to 50. And then there's actually two more restrictions. They're not in the problem because they are real life restrictions on x and y, okay? What can x not be numerically? Okay, so something we have to keep in mind at the end is it can't be any decimal or fractional values, right? Can it be any real number? Like, can it be any integer then? It can't be a negative number either. So I'm also going to write down here that x has to be greater than or equal to 0, and y also has to be greater than or equal to 0. Is everybody okay with these two restrictions I've added? These are just like real life restrictions that I can't work in like negative number of cases that I ordered, okay? All right. The next part says to write the objective function. What is our objective in this problem? Profit. So the objective function is really the profit function. I'm going to use a slightly different notation. It just looks a little different than before. You know how normally you guys write like f of x? We're going to use p for profit. And then how many things do you actually have to plug into your profit equation? Look at the backboard when we wrote it for the Legos. To calculate the profit, did we just plug in an x value? No, we had to also plug in a y value. So this looks kind of weird. They don't write p of x, they write p of x comma y. But does that notation make sense? They're writing x comma y because you're plugging in two numbers into your profit function instead of one. And which equation up here is our profit equation? The third one. So we're going to do 20x plus 30y to calculate the profit. So is everybody okay here with the fact that in our problem, the variables becomes the things that we're going to make a decision about? Here it's chocolate bar cases and popcorn jar cases that we're going to order. In our Lego problem, it was tables and chairs to decide to make. So that's where we're getting our variables from. The next thing is that our limitations or our restrictions are coming from whatever has been limited in the problem. In this case, it was how many units you could order and cost. In the Legos, it was large components and small components. So each limitation gives me a new little inequality that I can write for the problem. Okay? And then we have some real life ones. And then our profit equation, we're always trying to maximize profit in these situations. So that's what we're looking at as our objective function. So is everybody okay with the terminology here and how we're picking out which things are important? Okay. All right, so the next thing we're going to do is we're actually going to graph these equations, okay? Because remember, our goal in doing this was to not randomly guess and check, but instead to have kind of some guided guesses that we know are like feasible options. And so the graphs of those inequalities are going to show us the things that are actually allowed compared to us just randomly guessing and seeing if we break any rules. Okay, I'm going to go back and write down the equations we had while you guys are getting your graph ready. So 3x plus y was less than or equal to 40, and x plus 2y is less than or equal to 50, and then our, oops. Okay, so which quadrant are we really going to focus on for our graph here? 1, right? And the reason quadrant 1 is because, right, it's all positive. So we've put in a limitation that says we have to be greater than or equal to 0 for x, as well as greater than or equal to 0 for y, which places us in the first quadrant. Okay. Now I need to graph these other limitations. So 3x plus y being less than or equal to 40. I'm going to graph this using standard form. I'm not going to change it. I'm just going to keep it where it is. You could quickly change it into slope-intercept form if you guys wanted. But when I graph in standard form, I basically quickly pick out the x and y intercept. Okay. So some points that would be on this line, if I plug in 0 for x, what would y be equal to? So we're kind of pretending like it's an equal sign right now because we're not doing the shading yet. So if I plug in 0 for x, that's a 0 now, and I would just have y is equal to 40. So 40 is my y-intercept for that line. And then for my x-intercept, I'm going to plug in 0 for y. Okay. So if y becomes 0, then for x I get 40 divided by 3, okay, which is a little difficult to graph, but if I just understand that that is, let's see, 3 goes into 4 once, 1 left over, 13 and like a third, okay, if you're having a hard time understanding where to put that. Okay. And then I'm going to do the same thing for this second line. So my x-intercept here would be 25. Sorry, 50. If I'm doing the y-intercept. So my y-intercept is 25 and my x-intercept is 50. Is everybody okay with where I'm getting those numbers? So I'm plugging in 0 for x to get the y-intercept. I'm plugging in 0 for y to get the x-intercept. And so the reason I did that is it's going to make my graphing a little bit simpler since I'm focused on the first quadrant. So I'm going to kind of count by tens since some of my numbers are so high. I'm going to call that 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. Okay. And then from here, I'm going to just put both those lines on the graph so I can get a visual of like where are these points that work for both of these restrictions that we built. So I'm going to plot for this first line, the first restriction here, my y-intercept of 40 and my x-intercept of 13 and a third. And I'm going to draw a line. Oops, sorry. Sorry, you guys. Hopefully that's not the beginning of anything more than a sneeze. And then the shading for this would be trapped kind of in here because we're stuck in the positive quadrant. And if we plugged in a point, it would be shading below that boundary. So it would be here. Now I'm going to put the other restriction on that same graph. So this line here. So a y-intercept of 25 and an x-intercept of 50. And I'm going to put in this restriction. Sorry. and the shading for that would be here. Okay. And so does everybody see the region of possibilities? The points that actually make all of this true, they call this the feasible region. Feasible is a word for saying it's possible. So our feasible region is this shape right here. The two axes and these two lines making this random quadrilateral here, and all these points inside of here are options. Okay, so like 5, 10, that would be an option. Okay, so I could order 5 cases of chocolate bars and 10 jars of popcorn. But will that maximize my profit? So lucky for you guys, a mathematician studied this because they probably got really sick of trying all the possibilities, right? And it turned out that every time they did this, the maximum and minimum possibilities were not inside the region, but at the very edges of the region. So that takes our possibilities and narrows it down from many, many whole valued points in here to just 4 possibilities for maximums and minimums, the corners and the vertices of this shape. So 0, 0 is one possibility for the maximum or the minimum amount of profit. Then this intercept right here, which we found when we graphed that blue line, so it's 13 1/3 or 40/3, 0, is another possibility. We'll talk about the fraction in a minute. This point out here is another possibility, and I don't know exactly what that is at the moment, but I will figure it out. And this intercept here is another possibility, which was 0.25. Okay, so the theorem basically says you can try all the points, but the maximums and minimums are always the most extreme points of the shape. So you're just going to use the vertex points, which is great because it means if you have 2 limitations like this and you're stuck in the first quadrant, you'll only have to test 4 points instead of testing lots and lots of things, and you're guaranteed to find the minimum or maximum in those 4 points. Okay, so our 4 possibilities, if we look down here, you guys have already listed them, probably have 0, 0, 40/3, 0, 0.25. And this 4th point that I didn't label, how am I going to find that 4th point? Yeah, Morgan. Good. It's the intersection of 2 lines, right? It's like solving a system, kind of like our system of 3 equations and 3 unknowns, but luckily it's only 2 equations, 2 unknowns, okay? So we're going to solve the system of 3x plus y. We're going to pretend like they're lines and not inequalities because we just want to know where they cross. So there's our 2 equations. And I'm just going to go ahead and multiply the first one by -2. Is that okay with everybody? So when I do that, I'm going to change this equation by multiplying it by -2. I'm going to get -6x minus 2y equals -80. So hopefully this results in something that's decent here. So I get an x value of 6. So that tells me this other point that I didn't quite know has an x coordinate of 6. And then how will I find its y coordinate? So plug it back in. Yeah, to either of these equations. So I'm going to plug it into 6 plus 2y equals 50. So then 2y equals 44. And y is equal to 22. So 6,22 is my 4th possibility that could result in the absolute maximum or minimum profit for this scenario. Okay. Any questions on how we did that or why we did that? Okay. So 622 is my 4th point. So then what you have to do is exactly what you guys were doing before, but you just have a little more guidance this time. Instead of starting with no idea, you now have 4 possibilities. That is all, okay? And you need to check out those 4 possibilities. So you're going to calculate the profit for each one. So the profit of 0, 0, the profit, and we'll talk about this fractional amount. We really can't make order a fractional amount. We'll look at it if it's in the running for the maximum and minimum. If we feel like it's close, we'll go back and adjust to, like, if I can't order 13 1/3, I could really just only order 13. And so if I have to, I can check out, like, what if I plug in 13? Because that's really the possibility in this scenario, okay? And then we had 0.25 and 6.22. So go ahead and take a minute. So check your answers, and you can feel free to correct me because you all know arithmetic is not my strong suit. So make sure my answers match what you got. So if I use 0, 0, that's my minimum. Like that's where I'd make no profit. I didn't buy anything. If I bought only Hershey's bars, I could buy realistically 13, okay? And that would give me like $260 worth of profit. If I bought just popcorn jars, I can buy 25, which gives me $750 worth of profit. But if I buy 6 cases of chocolate bars and 22 cases of popcorn jars, it's within our constraints and gives me $780 worth of profit, which is the maximum. So the maximum profit is $780, okay? When selling 6 cases of chocolate bars and 22 cases of popcorn jars. Is this okay with everybody? All right, so what you guys need to do, your project directions are online. It's called the Linear Programming Project. It's actually in the same module as your weekly reviews because every unit are gonna have like a project of the week. So this is like your project of the week number 1. Sometimes they'll be shorter and longer, so you'll have different time frames for them, even though we call them project of the week. We'll usually spend 1 or 2 days in class discussing the concept. We're kind of exploring it, and then you guys will have a week or more than a week in this case, to do whatever write-up is required of you. Okay, this project's a little unique in the fact that you're like figuring out a business and stuff. You're not just solving one problem. All of your problems will be different. So it doesn't follow like a specific write-up guideline. You just do what the project says. It tells you at the bottom what you need to turn in. So when we look at those project requirements, I'll go ahead and do that. See, let me get to your course. You have one thing that's due by Monday. It's not due till Monday night, but that is basically what your idea is. That's what I want to know. So here's project of the week number 1, your linear programming project. When you click on the directions, you're taken to a Google Doc link that tells you all of the specifics. So the final due date is Wednesday, October 9th. You can work alone or in pairs. So if you want to work with someone, that's fine. Okay. By Monday at 10 p.m., I want an idea of what your business is, where it's located, what you're selling them for, how much you would buy them for. And it doesn't have to be realistic. So like I said, I've had someone sell rainbow and sunshine and stuff like this. It's totally okay. And here's where it gets a little hard and where you're going to have to adjust things. You're going to tell me what you plan on selling things for and how much money you plan on making, but we want both of your constraints to affect the outcome. So you saw when we draw that figure, it made a quadrilateral because both of the lines came together at a point. If you don't set your numbers right, one line will just be a lot smaller than the other and you'll just have a triangle instead of a quadrilateral because one of the constraints is so small that it's like you can't even, the other one doesn't matter. We need both of yours to matter. So that might be adjusting your numbers. Making a problem is actually harder than solving a problem. So that will be part of the issue you guys have. We're giving you one thing to look at, and that is that we're telling you $10,000 is what you have to spend. So one of your constraints is however much it costs you for your first product plus however much it costs you for your second product must stay less than or equal to $10,000. Okay, and we're taking real world and simplifying it big time. You don't have to tell us the rent of your building or how much the bills are. We're just saying product cost. So product cost under $10,000, we've set one restraint. You're going to set the other restraint. Do you only have enough space to store 400 items like the one we saw? Okay. Do you only have enough time to make a certain amount of these? And you'll set that constraint, okay? And so by Monday, you're gonna have the information that you're planning on starting with, and I will have the understanding that you're gonna stick with that business idea, but you might have to change up all your numbers. If you pick numbers that when you go to sketch it out, don't really both contribute to what the solution of the problem might be. Does that make sense to everybody? So really the focus right now, I want you to focus on, do you want to work alone or with a partner? And come up with the business idea by Monday, so that Monday night you can easily submit something that tells me I'm working by myself, or me and so are both doing this together, so I can give you both credit for it and then group you for your final project submission. Does that make sense to everybody? Okay, and then we'll have some time in class that we'll kind of like let you guys discuss it or be working a little bit on your projects. Otherwise, you'll come in to tutorial if you need help with the numbers and stuff like that, okay?